Assalamu alaikum everyone. Today our topic is neuromorphic computing. Now we are going to present our report. Introduction. Neuromorphic computing. Neuromorphic computing is one of the newest advancement computational technology. They are modeled based on human brain or nerve system. This is different from an artificial neural network, which is a program run on a normal computing that imitate the logic of human brain. We all know the neuromorphic computing is the hardware version and the neural network is the software version. The common computers work in binary, that is in 1 or 0, yes or no, where neuromorphic computing works in little more flexible way. Instead of using electric signal to mean 1 or 0, designers of these new chips want to make their computer neuron talk to each other the way biological neurons do. Now let's move to our theory part, which is presented by our group member Mehedi Hossain.
Neuromorphic computing gets information primarily and biology while neurons are likely and information by species and different intervals. It is fast, basic analog balloon. That's what neuromorphic arithmetic does much closer cognitive process than normal and traditional neural process. This really just an evaluation enable computer learning. Like traditional neurons made two first neurons are the actual nodes for information. These two first transfer electrical signals using analog circuit. One of the biggest applications of the neuromorphic computers come from derivation from biology. This application has lot of potential to exploit in AI. Computer chip architecture. This chip also any number of parallel and algorithms or operation. It depends on the distinct system and CPU. In the maintenance, many of these implementations primarily used and research capacity. It may not be long before the interest and part of high performance computing performance speaks and parallel operations. There are two main considerations when developing or redeveloping and implementations and scientific algorithms for neuromorphic computing. Design fully parallel algorithms not required but important to advantages of neuromorphic hardware if you can. Recent developments is neuromorphic hardware may be built and is usually currently neural systems network currently running with somewhat graphics process unit GPU. Functions is for the human brain is still AI. But but two competing and developers need to create something API set application programs interface. Programming model language for making neuromorphic computers and general public. Despite its challenger, researchable find new ways and access performance of the new architecture. In short, neuromorphic computing can be useful and designing the additional benefits of faster and algorithms and better understanding of the brain. Let's move our materials method part which is done by Tohura Peea.
In materials and methods, we can see that the system can learn to generate applications from these calculations in order to mimic neuromorphic functions. Hardware and equipment support systems and applications as well as neuro-inspired models, algorithms and learning approaches are all examples. Also, higher connectivity and concurrency, low energy consumption, memory cluster are all important and unique criteria for neuromorphic architecture. If we compare to typical von Neumann system, it has a higher capability for doing complex computations at high speeds, resulting in lower power consumption and smaller footprint. We can see that neural learning methods can be classified using event sequence and time series classification. Also, depending on the learning environment, neural network learning methods can be classed as supervised and unsupervised. The network is directly introduced into the environment without delivering standard samples in unsupervised learning, and the learning and working are merged as a stage. In the result and discussion part, we can see that effective learning algorithms enable neural networks to generate various goals and object representation. Like character recognition has a wide range of practical applications in a variety of industries, including car number and license plate identification in transportation, postal, transit, and document management procedures. Three types of character recognition systems are now available, like neural networks, probability, statistics, and fuzzy recognition. Now the other half is going to describe Redwana Momotaj.
So, the discrete hopeful neural network, on the other hand, includes an associative memory function which is useful for anti-noise processing. Many researchers have sought to apply the hopeful network to numerous fields in recent years in order to replace conventional methodologies to handle challenges. Hopeful neural networks are used in a remarkable variety of scientific disciplines, with data classification, pattern recognition, image recognition, etc., among the primary technological areas they cover. Now, moving forward to our next part, which is conclusion. The neuromotor framework's major main force is ongoing execution. These gadgets can commonly perform neural network processing applications faster than von Neumann frameworks on amount of parallelism and equipment speed up computing. To emulate neuromorphic capacities, the framework can gain and produce applications from these estimations. Neural network learning strategies can be delegated, regulated, or unaided, picking up contingent upon the learning environment. Various tasks require various formats for various items to match informational collections, and afterward, object information should be input into a neural network algorithm for learning. So this was it for our today's presentation. We're ending our presentation here. Hope you all find it informative and helpful. Thank you so much.